Let's do another example. Let's look at this problem. Let's take limit as x goes to 0 of the square root of 1 minus cosine squared of x over x. And actually, let's take the limit from the right, meaning that we're only going to be considering those x values that are bigger than 0. So how can you do this? So problems like this are all basically equivalent or coming from the fact that we know that sine of x over x tends towards 1 as x goes to 0. In other words, the limit of sine x over x is equal to 1, limit as x goes to 0. And in order to make a link between these two, not that every limit problem is going to involve sine x over x, but since we just happen to study it, there are a lot of problems that you can do using the limit laws and other techniques. Here, this comes to us from a trig identity. If you remember that sine squared of x plus cosine squared of x equals to 1, then you're going to get that sine squared equals 1 minus cosine squared, which is going to tell you, taking square roots of both sides, actually, that the absolute value of sine of x is equal to the square root of 1 minus cosine squared of x. Now, so let's just substitute this in for what it's equal to. So this is really nothing but the limit as x goes to 0 from the right of absolute value of sine of x over x. So can we solve that? And yeah, we can solve that. So as we go from the right, that's going to say that x is bigger than 0. And in fact, as long as x is bigger than 0 and as long as x is less than pi over 2, in fact, sine of x is going to be positive. So it's going to be equal to its own absolute value. You can see that from the graph. So if you look here at the graph of sine of x, actually it's going to stay positive all the way up until pi. And then it'll go negative and then become positive again, or whatever. But when we're taking the limit as x goes to 0 from the right, we're considering values that are very close to 0, but positive. And certainly it's going to be true that sine of x is equal to x. And even if we weren't doing that, if we were just taking the limit, if we were just taking the limit as x goes to 0 without considering these values from the right, we'd have the issue that this would always stay positive. And this would be positive sometimes and negative other times. So from the left, this would be close to -1. From the right, it'd be close to 1. And we wouldn't be able to do it. But since we're just considering these positive values, sine of x in absolute value is equal to just sine of x. So knowing that I'm taking the limit from the right, I can make the replacement absolute value of sine of x is just equal to sine of x over x. And sine of x over x limits towards 1. So that's the answer. Let me explain what I was talking about over here just a second ago a little bit more fully. So if I had been asked a different problem, if I had limit as x goes to 0 from the left of this function, and which I know is equal to absolute value of sine of x over x. When you're taking the limit from the left, then sine of x is negative. So its absolute value being positive would have to be the negative of sine of x. Let me say that one more time. So if you go back to the graph of sine of x, limit from the left, x values approaching 0 from the left, the y values are negative. To make the absolute value positive, we have to take the negative of sine of x. And so we get negative sine of x over x. And then negative sine of x, that's the same thing, of course, as multiplying by negative 1. And then using that limit law, that constant multiple rule, you can pull out the negative 1 or pull out the negative sign. The negative sign. And so you end up with limit as x goes to 0 from the left of sine x over x. And sine x over x tends towards 1. So we actually get negative 1 for the answer. So when you look at this problem, this has a right-hand limit equals to 1. It has a left-hand limit equal to negative 1. Because those limits don't match, if I had just said limit as x goes to 0 of this function, that would have been a problem. That limit doesn't exist because you're approaching different y values from different sides. So that's how to do that problem.